students. In the last lecture, we discussed about reversible chemical reactions. These are the reactions in which the reactants A and B react to form products L and M, but these product formed L and M can react back to give back the reactants. The arrow towards the reactants is called backward reaction and towards the product is called forward reactions. So, what happens at the beginning? The rate of reaction, forward reaction and backward reaction are not equal. But as time goes on and the reaction goes on, the concentration of products start to decrease. We can show it like this with the help of a graph. The concentration of reactants is falling. X axis it is rate of reaction, on y axis we are representing time, and after some time there is sufficient quantity of products L and M. So, since we know that more of the reactant is formed, more will be the rate of reaction. So, the rate of backward reaction will start to increase. This is forward reaction which is decreasing, this is backward reaction which is getting speed. But after some time we will reach a point where the rate of both reactions will remain same and there will be no observable change in the system. That means after this point E, no change can be observed in the system. So, since we cannot observe any change, that means system is said to be in a equilibrium. Sometimes it is said that equilibrium is reached when rate of forward reaction becomes exact equal to rate of backward reaction. But it is more appropriately said that equilibrium is reached when rate of forward reaction and backward reaction does not change with time. So, they are not normally equal, but they are not changing with respect to time. So, after this point E, which we call equilibrium, no observable change in the system. That means we cannot observe any change. So, this state is called the state of equilibrium. So, now moving on to next topic, which is called law of mass action. This is related to the rate of chemical reaction. So, consider a chemical reaction which is general A to B, which is forming product. According to this law, the rate of this chemical reaction is directly proportional to how much of A is being used and how much of B is being used. Anything in chemistry which is written in square brackets, it represents concentration or amount of the substance. So, rate of any reaction is directly proportional to the concentration of reactants, or we can normally write it like this: rate is equal to K, removing the proportionality constant, concentration of A and concentration of B. So, now we change this reaction into a specific one if there are coefficients in the balanced chemical equation. These coefficients normally go to the powers of the concentration term. So, that means small a will go over concentration of A and small b will become the power of concentration of B. For example, 2H2 plus O2 giving 2 molecules of water. According to law of mass action, rate will be equal to K, H2 twice and O2 power 1. So, this is law of mass action for any chemical reaction. Once again, rate of chemical reaction is directly proportional to the concentration of reactants, and if there is any coefficient in the balanced chemical equation, that coefficient ends up being at the power of concentration term. Moving on to the next topic, that is law of chemical equilibrium. Consider a reversible chemical reaction in which A times of A reacts with B times of B to give L times of L and small m times of capital M. So, what we will do is, this is our forward reaction, this is backward reaction. We will apply the law of mass action on both reactions. So, what was law of mass action? What is forward reaction? Forward reaction is A times A, B times B gives the products. So, for forward reaction, the rate of forward reaction will be directly proportional to concentration of A and concentration of B. Now, the coefficients are small a and small b, they will come into the powers. Similarly, for the backward reaction, now L times L and small m times m are the reactants. So, therefore, the rate is L raised to the power small l and m raised to the power small m. Removing the coefficient proportionality constant, we get for forward reaction it is A raised to the power A and B raised to the power B. Now, since it is for forward, we will write F here. Similarly, this is KB, L power L and m power small m. Mark it as equation 1 and equation 2. Now, from the definition which is generally used, equilibrium is reached when rate of forward reaction is equal to rate of backward reaction. That means equation 1 is equal to equation 2, or in other terms it is Kf A power of A and B power B becomes equal to Kb L power small l and m power small m. Now, taking the ratio, what we get is Kf divided by Kb. What we need to obtain is Kf divided by Kb. So, this comes out to be Kf by Kb, A times A and B times B becomes L times capital L, m times small m, or Kf by Kb becomes L times L divided by M times M, or we can say that this is concentration of products divided by concentration of reactants. So, this term Kf by Kb, it is generally represented by K, or we sometimes represent as Keq, which is called equilibrium constant. Also, we can write K is equal to L power L, M power M, A power A, and B power small b. This whole equation number 2, is known as law of chemical equilibrium. So, now this is equilibrium constant. We will write